So we've been working for very hard for 3 days on writing equations of lines, and let's just talk about what we've seen so far to make sure that this makes sense to you. We know right now that there are two forms of linear equations. We can call those functions if we want to, but right now we'll just refer to them as an equation. The first form looks something like this: y equals 2/3 times the quantity x minus 6 plus 7. And we learned that we can manipulate this algebraically to get it into a different form. So the first thing I would do is distribute the 2/3. So 2/3 x minus 2/3 times 6 plus 7. I can then simplify this by taking 2/3 times 6, which is 4. So I get 2/3 x minus 4 plus 7. And that gives me 2/3 x plus 3. Okay, now this is the form that I think most of you are familiar with. But what we're saying here, the connection that I want to make, is that this form of the equation and this form of the equation over here are exactly the same. They look different, but they have the same exact relationship between x and y. Let me put this another way. These two functions are in different forms, but they graph the same exact line. So let's go ahead and verify that this is true. So when I open up this graph here, and I have my first form of the equation, 2/3 x minus 6 plus 7, and I go ahead and graph that. So there's that line. Great. What I'm saying is that 2/3 x plus 3, even though it looks very different than the first equation, will graph the same exact function. And we can see that when I light it up in green, it works. So this has been verified. So we can get to these two different forms by doing just a little algebraic maneuvering. Now, let's put some vocabulary to this. This form of an equation, which you're probably not as familiar with, actually has a name. It's called point-slope form. And we'll get to why it's called point-slope form, but in general, a general representation of this would be y equals m, the slope, times x minus x1 plus y1. And we'll learn about these x1 and y1s in just a few seconds. Then we have this form of the equation, which you're more familiar with. This is called slope-intercept form, and it's in the form y equals mx plus b. Again, m is the slope, the x is simply your x, and the b right now is 3, but we'll talk more about that b in a second. But right now, let's just make the connection that slope is m, and we can see that the slope of 2/3 is consistent for both of these lines. Okay, so here is the official definition of point-slope form. Given a point on a line, x1, y1, and some slope m, the equation that graphs the line can be written as y equals m times the quantity x minus x1 plus y1. Now this is very abstract, but keep in mind that x1, y1 are going to be two values. All right, they're going to have numerical value. This y and this x are going to stay as variables because we need an x and a y in order to make that connection to graph the line. So here's a quick example of what this looks like in action. Let's write the equation of the line that's passing through the points 2, 1 and 7, negative 2. Well, using what we know, we need a slope, right? So we got to calculate the slope. So we're all pretty good at calculating the slope by now. y2 minus y1 over x2 minus x1. So I'm going to take negative 2 minus 1 over 7 minus 2, and that gives me negative 3/5. But now, since I have this official definition of point-slope form, what I can do is I can go right to the equation. So I can write this equation as y equals negative 3/5 times the quantity x minus 2 plus 1. And you might be saying, well, where'd this x minus 2 plus 1 come from? Well, it came from the fact that they gave me a point, 2, 1. So based on this definition up here, it's x minus x1. So that's going to be x minus 2 plus y1. Well, the y1 is a 1. But there's another way that I could write this. Instead, if I wanted to use the point 7, negative 2, I can say y equals negative 3/5, that's my slope, times x minus 7 plus a negative 2, which I would clean that up. And we can write that as negative 3/5 x minus 7 minus 2. Now let's just take a second and verify that this works. So if I go to my graph and I have these points, and these points are going to be the point 2, 1 and 7, 2. Okay, there are those points. The first equation was negative 3/5 times x minus 2 plus 1. Well, let's light that up and see if it in fact graphs the line. There it is. Perfect. But we said I could also use, instead of that line, I could say negative 3/5 times x minus 7 minus 2. And there's that line. So when I light both of these up, they both graph the same line, but they look a little bit different. And that is how point-slope form works.